Hello, everyone. My name is Marcy Samuelson, and I am Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's webcast, RackWare Enables Container Migration to Oracle Cloud Container Engine for Kubernetes. We are very excited to be able to share with you how RackWare is adding support for the Oracle Kubernetes Engine. If you have any questions during the workshop, please put your question in the Q&A area, and we will answer your question as soon as possible. The webcast is being recorded, and we will make it available shortly after the webcast concludes. Again, thank you for joining the webcast RackWare Enables Container Migration to Oracle Cloud Container Engine for Kubernetes. This webcast will be presented by Tom Matters, co-founder and Chief Technology Officer at RackWare, Aniket Kulkarni, Senior Technical Director at RackWare, and Gilson Malo, Director of Product Management at Oracle. At this point, I will turn it over to Gilson.
Thanks, Marcy. Happy to be here today with Todd and Aniket from RackWare to share some details of this joint solution we have been working in the past months. For information, this is the Oracle Safe Harbor, and I'll give you a few seconds to read it. If you are watching the recording, feel free to pause it if needed. Before we jump into RackWare's content and demo, as usual, let me give you an overview of Oracle Container Engine for Kubernetes, also known as OKE. So, why Oracle Kubernetes? OKE is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. Oracle Kubernetes is based on the upstream version supported by the Cloud Native Computing Foundation, CNCF. So there's no vendor lock-in, and that also means that everything you have tested with Kubernetes on premises can be ported to OKE without the need to rewrite any line of code or re-architect it. So use OKE when your development team wants to reliably build, deploy, and manage cloud-native applications. Oracle's cloud-native services leverage the highly performant next-generation Oracle Cloud Infrastructure, also known as OCI. These services can be categorized into application development plus operations and observability plus messaging. As you can see on this slide, we provide several cloud-native services that, combined with OKE, will give you a robust and scalable cloud-native services environment. For example, we have streaming service, which is fully Kafka compatible, logging, compatible with Fluentd, native monitoring, notifications, events, API gateway, infrastructure as a code that allows you to run your own Terraform stack in the cloud through our resource manager UI. Along with that, we also provide functions and several other services that will assist you with your most demanding workloads. And since OCI and OKE are based on open standards, you're more than welcome to bring your own open source software that you're familiar with to use along with Oracle Cloud Native solutions. So what's Oracle doing with the open source community? Well, let me explain what we're doing on our side. Oracle is a platinum member of the Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation project. So we're very serious about open standard services and supporting the Linux community in general. As I just mentioned a few seconds ago, Oracle Cloud Native Framework is based on open and conformant CNCF standards. So again, no vendor lock-in. And applications built on that framework are portable to any Kubernetes conformant environment or on any cloud or infrastructure. For example, applications running on WebLogic on premises can be easily containerized or put into containers and then lift and shift into Oracle Container Engine for Kubernetes without re-architecting or rewriting any code. This makes the migration to public cloud very easy. In addition to that, Terraform configurations can be reused across Oracle Cloud environments, so they can be modified to be used in other cloud environments as well, and be automated with Oracle Cloud Resource Manager, which is basically our UI option that allows you to run the Terraform stacks, and so much more. So this slide contains just some few examples of what Oracle has been doing in regards to open standard services and in regards to what we're doing about supporting the Linux community in general. Oracle's second generation cloud infrastructure, known as OCI, provides bare metal, virtual machines, containerized compute, GPUs for performance-intensive workloads, such as for AI and machine learning, and a variety of cloud storage options like block, object, file storage, and archive. OCI offers a fantastic array of services for developers to build modern applications, and OKE uses OCI as the main platform for its services. Regarding the framework and programming language, we don't restrict users to one or two programming language options only. So you have the choice to use any programming language and framework like Java, JavaScript, Node, Python, Ruby, etc. And you can use any DevOps tool as well. In addition to that, we provide a set of free tools like Visual Builder Platform for your DevOps framework, but you are more than welcome to continue using the same tools you're familiar with, like Jenkins, GitLab, and others. This is the enterprise cloud you have heard of, that provides an integrated data platform for the most demanding users. This includes our flagship autonomous database, but we also offer the choice of other databases like MySQL and Microsoft SQL Server, for example. Finally, we also provide several services to help you manage, secure, and monitor your applications. And we'll share more details in the next slides. Okay, now let's talk a little bit more about OKE and Oracle Cloud Infrastructure Registry, or OCR. OKE is a developer-friendly and enterprise-ready managed service that runs a highly available Kubernetes cluster with the control, security, and performance of Oracle Cloud Infrastructure, while keeping pace and compatibility with the CNCF ecosystem. For example, OKE supports Kubernetes Helm for easy deployment of Kubernetes apps and several other features like bare metal support for worker nodes along with virtual machine and HPC shapes. OCR is a highly available container registry service that enables users to easily store and share their container images. OCR allows users to push and pull images with the Docker CLI or pull images directly into their Oracle Container Engine for Kubernetes deployments. OCR is a Docker v2 compliant and can work with OKE or other container engines as well. So interoperability is assured with both OKE and OCR products. To recap, we have covered some of Oracle open source initiatives and DevOps solutions along with a quick intro of OKE and OCR. Now let's talk about pricing options. The gray shaded area on the left designate the functions that Oracle manages for our users, including an integrated registry, image storage, and a fully managed container engine for Kubernetes. Oracle will manage the etcd and master nodes of the Kubernetes instances in a high availability setup for the users, and upgrades to new versions of the Kubernetes will also be supported in the container engine dashboard within the OCI console, so it's very easy to upgrade your OKE master nodes along with your node pool servers, and you decide when to do it to mitigate downtime situations, for example. Users will manage the cluster worker nodes that are set up by the managed service for that instance in their own OCI account and tenants. That's the shaded in the blue above on the right. Users do not pay for any of the Oracle managed container infrastructure. That's the control plane, the gray area on the left. The control plane enables you to configure these services, maintain operations, versions, availability, and etc. Users will pay only regular fees for the compute, storage, and networking used in the data plan. That's the blue area on the right, where your applications will run and where your data will be stored. By the way, did you know that some cloud providers charge you for the master nodes and services? I mean, that's the control plane you see here on the left side, which is completely free in the Oracle Cloud. So OKE and OCR not only provide a reliable and robust environment, but also a very cost-effective platform for you and your users. I have a couple of more slides left, so let's use them well and talk about some of the unique capabilities we have available for our users, like how about using OKE with other Oracle services? Well, Oracle provides service servicing to make it easy for you to get your microservices talking to other Oracle Cloud Native solutions. Oracle Service Broker is an implementation of the Open Service Broker API that you can use in a Kubernetes cluster to provision and bind to OCI services that your application depends on. It includes integrations with key OCI services like the Autonomous Transactioning Processing Database or ATP, Autonomous Data Warehouse or ADW, Oracle Database, Streaming Service, and Object Storage, and additional integrations are being built in as we speak, and we will announce them soon. The main key benefit of the Service Broker is reducing the complexity in the app deployment. So it's very easy to get your OKE microservices talking to other Oracle Cloud services that your application requires. Cool. What about persistence? How to make sure that the data is persistent with OKE? As you might know, applications can be categorized as either stateless or stateful. Containers are well suited for stateless app, but require the use of external data stores for stateful apps. For example, stateless apps do not require persistence, like I said a few seconds ago. They are easily redeployable and easily scalable. They can be easily containerized. And a good example of a stateless app could be a website that serves the same static web page to all clients. Well, what about the stateful apps? Well, the stateful apps, they require persistence. They are more useful for complex use cases. And an example of a stateful app could be an e-commerce website that keeps track of your cart as you shop. So basically, keeps track of your state. OKE provides services and capabilities for both stateless and stateful apps. And along with that, you will also have the capability to integrate your apps with Oracle Flagship's Autonomous Database and storage services like block and file storage service as well. Finally, here are some highlights of new features we have announced recently that I would like to share with you. For example, we have made available the Kubernetes version 1.17. We now support AMD new flagship, which means that your worker nodes can use the new feature of selecting a specific amount of memory and CPU for your worker nodes. We have launched the container storage interface support for OKE as well. You now can change your worker nodes properties and shapes if needed, and a lot more. So check our documentation for additional details in regards to what we have released and what's coming out. And now that you know more about Oracle Cloud Native Services, I'll turn it over to Todd and Ankit from RackWare and let them share some of the cool details about this joint solution that we have worked in the past few months. Thank you.
Thanks, Gilson. Hello, everybody. I'm Todd Matters, the CTO at RackWare. You may know a little bit about us. We've done multiple webinars with Oracle. Our first product, the one we've been deploying for a while, is RMM, RackWare Management Module. This is a server-based solution that does migration, DR, and backup for servers. at the server level, at the OS level. We also have a hybrid cloud management solution. There's a whole software management suite for cloud. It's very enterprise focused. And I'm very pleased to announce that we are significantly extending the product line for Kubernetes and containers. This product is called Swift, and we are applying the same tenets of the RMM relative to migration and DR to Kubernetes and containers. So just a little bit about the solutions. So essentially, the software can get pretty much any workload onto Oracle Cloud Infrastructure, OCI. So from an on-prem perspective, the server-based solution can replicate and sync pretty much any server, whether they're physical servers, right, running large, complex applications, or pretty much any hypervisor. So whether they're virtual machines or containers running on VMware or physical servers or Hyper-V, take your pick, the software can replicate and sync those workloads into OCI. Just as important, though, the software can replicate and sync pretty much any workload from any cloud, at least any major cloud. So if you have workloads running in Amazon or Azure or Cloud Platform, Google Cloud Platform, the software can get those workloads, migrate them into OCI or configure them for DR and backup. So there's a huge degree of flexibility. It opens up a very broad scope of applicable servers to take advantage of the outstanding OCI platform. Now, from a Kubernetes perspective, first, again, these tenants are the same. So if you have on-prem Kubernetes and containers, the Swift product can replicate and move those workloads into Oracle OKE. This includes anything running on Docker or OpenShift or VMware for that matter. Likewise, Kubernetes and containers running in other clouds. RackWare Swift can replicate and sync those to OKE as well. And that includes Azure, Amazon EKS, the entire suite of OpenShift and Google Cloud. So how does this work? So let's say on the left-hand side, we have a set of containers and we want to replicate those into OKE. First, we would deploy this Swift software. Now, just like RMM, you would deploy the Swift software. A best practice would be deployed on the target side, although technically it can be deployed anywhere as long as it has network connectivity to both sides. But anyway, you would deploy the software. The first step then is Swift would connect in to the Kubernetes cluster. You just tell it the IP address, the software connects in, does a series of query operations to understand what's there. Now, the next step then would be for the software to take snapshots. These are transient snapshots of all the storage associated with it. And then this is really cool. Swift will deploy its own container to run its own software to perform and complete the replication process. Now, in this example, we're showing a replication directly from the origin environment to the OKE environment without any intermediate store and forward. So after the replication, the container and the entire Kubernetes environment is deployed in OKE. It can be fully managed and it's fully functional as it would normally be in OKE. Now, the software transparently takes care of any differences in storage. You can right-size storage during this process and converts to whatever the desired storage type is in OKE. Now, there's another important advantage, another important feature, I should say, and this is very useful for the DR use case. This provides a low-cost DR use case, but there's also advantages to this solution for a migration as well. So the software can do a store and forward, just like the RMM. The RMM can do a store and forward of server images. Swift can also do a store and forward of your Kubernetes and container objects. The way that this would work, again, you would deploy the Swift software. The process is essentially the same, connects into the Kubernetes cluster, takes the snapshots, copies the data. But here, Swift will copy the data and store it in a storage resource. This storage resource can reside in OCI. Now, this would just be regular block storage that the Swift product would manage. And then at a later point in time, you can complete that replication process. You click the button, tell Swift to complete the Kubernetes containers, then it will deploy and create the appropriate objects, copy the data, and again, at the completion of this process, those containers and Kubernetes objects are entirely managed by OKE with all the advantages provided thereof. So the big advantage to this approach, especially for disaster recovery, is during steady state, you're not using any compute resources. You are using some storage resources. And then whenever you want to do a DR test or it's a real failover, only then will Swift provision the appropriate resources. Only then are you really being charged for them. So this is an excellent example of using cloud technology with very current software like RackWare to provide economical, but at the same time meet all your very important application needs for both migration and disaster recovery. So to go through and summarize some of the differentiators, this is a true any-to-any. Doesn't matter what your on-prem Kubernetes environment is, or regardless of what cloud it's coming from. And importantly, the software will transparently make any storage changes. A lot of times storage is the Achilles heel in terms of trying to do migration or replication. This is a file-based solution. The software is not blindly copying sectors from one side to another. So because it's file-based, you can right size your storage, make it bigger or smaller. This is also more efficient as well, since the software only copies used data. So if you have a very large volume on the origin side, it's not going to copy all those sectors. It'll just copy the used data. And again, as this is file system based, this allows for easier and deeper automation. Now, automation is what it's all about. You need to keep your labor costs to a minimum, avoiding human error, and the software does just that. It also supports dynamic provisioning and pre-provisioned. So again, you can migrate directly to target objects, but for a DR use case, this can be low cost. It can be a store and forward where you're only consuming storage resources during steady state, and then your Kubernetes and container objects would only be created if there was a real failover or if you were doing a DR test. Now, I mentioned the DR test. So it's important to note that the DR test would be completely non-disruptive to the production environment. It would be a complete like for like from origin to target. So you can run through all of the important functions that you would need to in the target environment. And it's also very easy cleanup. As soon as you're done with the testing, the temporary testing objects can be deleted. The syncs can actually run during the test, or they can be resumed, and you're up and running with a minimum of effort, and at the same time verifying that you have a fully functional DR site in the event that you needed to use it. So at this time, I'm very happy to turn this over to Aniket. Aniket will be doing a demo for you. Aniket, take it away.
Thanks, Todd. Hello, everyone. My name is Aniket Kulkarni. I am a Senior Director of Development at RackWare. Currently, I'm leading the development of RackWare Swift product. Today, we would see demo of Swift with one application, which is WordPress, migrating from Azure cluster to Oracle. And on Azure side, it's using Azure disk storage, and on Oracle side, it will use Oracle OCI block storage. So you can see it's a cross cloud and cross version syncs as well, because Kubernetes version differs on both sides. Also, WordPress has two parts, so WordPress application and DB. Now look at the actual source and target application and environments in general. then we'll start the replications. And before we go, you can see volume types also change on both sides. So here's our source cluster, which is Azure AKS, Azure Kubernetes Service. It's running in US West. It's version 1.17 and it has node pool with 2 nodes, and they both are also running at the same level 1.17. And from here we'll migrate to OK, and we have deployed actually Kubernetes dashboard under this cluster, which is configured as a load balancer type. We'll look at that in a minute. And here's our Oracle side, OKE, and here we have target site created at 1.16 version, and we'll be doing now cross version and cross cloud migrations. And here also we have like a node pool with 2 nodes, and nodes are again running at the same version of 1.16. Now let's look at the Kubernetes dashboard on both sides. And since we don't have direct connectivity between Swift and 2 sites, because Swift is running in data center, it's gonna do replication using public IP or LAN. And we have this dashboard for the source. Here's the namespace where application is running, and you can see WordPress and DB both are running its services. And on the target side, we have this namespace created DR WordPress, and nothing is running. We have some secrets created, but that's created by the GUI. And also there is a container image credentials, the Docker registry credentials configured for our use. And here, like you can see, we have on source side services, pods for both, and also volumes for both. And there are few config max and secrets created. Also, WordPress service is configured as a load balancer type. So we have public IP for it, so that we can access it from outside, because again there is no connectivity from data center or where Swift is running to actual cloud. And here's that application running. Let's connect to admin interface. There are some test blocks created. WordPress is a blogging application, and we have some test blocks created here. So we'll log into admin interface now and look at few page configs, because after replication we'll verify that on the target side. We have few test pages created, one we just saw, and let's look at now dashboard. Here's the Swift dashboard. Let's log in, and it's running in data center. You can see from IP. So let's go to KTS administration. So here we'll see all the Kubernetes clusters which are configured. I have already configured 2, but it's easy to configure the details. For local cluster, you just need IP address and API IP address, and then service account token, which has decent permissions to access all namespaces which you want to replicate. And for Oracle Cloud, you would input cloud credentials, and it will go ahead and discover the cluster. And this configuration is a one-time step. So I already configured these two, and we can see that like it went ahead and has discovered all the details. And let's go ahead and in fact look at the namespaces which we would be replicating. It has discovered all those details. And here's our source, and we can see like a 2 pods running. Let's start replication now. It's fairly straightforward step, and right now nothing is running. I'll go ahead and add. I'll select the source cluster, then I'll select the target cluster as OK, and then select the namespace which we want to replicate. Select the required namespace on the target side, and again you can select the namespace for replication, the entire namespace, or select few applications. I'm going to go ahead and select the entire namespace. You can do pre-post scripts here, specify they will be run before and after sync, and also you can configure YAMLs to apply on both sides before or after sync. You can also do storage class specification, what you want to do for target. Let me specify regions for flex volumes on OK side. And and we are not going to apply YAML in this demo, but it's fairly easy to apply. You can just drag drop your YAML and it would be executed on the respective cluster before or after sync. Now let's do more options, and then we would select pod config, which is run for the transient time during sync, which is RackWare pod run. It doesn't need any special privileges. Since now Swift is running into data center, it doesn't have any VPN or special access on both sides of clouds. I'm gonna go ahead and select the load balancer type for that transient pod where we'll communicate. And Swift will use HTTP and SSH protocol. It encrypts data on both sides, so you need one data port and one control port. I'm going to select those ports manually. You don't have to, it will auto select for you from service port range for the Kubernetes cluster, but I don't have that whitelisted in Cloud Firewall in this particular case. And specifying this explicitly will make Swift go ahead and open those in Cloud Firewall on both sides. And you can also skip the validations. By default, Swift will do validation of your application after it is replicated and only finish sync once application is up. You can skip that. Also, there is a dry run mode, which when you use will tell you how much data would be replicated, but it will not do any real sync. Let's start the job. And our sync is running now. Let's go to progress, and we can see that it started doing a lot of things under the hood. And we'll see some nice progress checkpoints. Let's go to the target dashboard and refresh this. You can see that volumes are created now, and there is a pod created for RackWare service, and that's a transient service and transient pod, and it's gonna get created with the config we told it to. And that pod is up now, so you should see data being replicated now. First it will replicate data, and then it will replicate any missing objects. It will also do delta sync, so if anything comes up in namespace which is not already replicated, it's gonna replicate that in next syncs. You can do as many syncs as you want, and after the initial replication, it's gonna do delta transfer. So if any data changed on any of the volumes, it's gonna only transfer that changed data. Its data transfer is about to complete, and then we should see that it replicating rest of the application configuration, including various objects. And we can also see that volumes are converted to respective types which we wanted. And data sync is complete, started replicating the objects, and we can see that objects coming up now. It's all objects are replicated. It's now going to verify the application status on target, and sync is complete now. Let's go on target and verify our application is up. You can see it did good chunk of things to complete the replication. Okay, so our application is up. Let's scroll down and then connect to our WordPress app. Since it was a load balancer type on target, we should be able to connect, and here is our application. We can see already that it's up and our blog is up. Let's connect to admin interface to verify all our pages. I'll connect with source credentials, and you can see it's up. Let's connect to the post. Now you can see all the source pages are replicated. Now, as for a delta sync test, let's do this. Let's create a test page on the source side, and it's a dummy page, and we'll put some data there. It's a dummy blog basically, and we would do sync and verify that page gets to the target. This is source side, and let me publish it. Okay, our page is published. Now let's click on post, and we can see that all the pages are there. Now let's create a dummy page on the target too. So what's going to happen is after sync, it's going to transfer only change data from source to target, including objects, and then after sync, target would be again replica of the source, so any target pages we created should be going away. We'll verify that. And here's the target page. Let's publish this too. And our page is published. Now let's go to post, and we can see that this is the page created, and we see different pages on the source now. So there's a difference. Now let's start one more thing. I'll select again Azure cluster as source. Then I will select OK cluster as target, and then select the required namespaces, production WordPress to DR WordPress. Again, we are replicating all the applications. We are not changing storage class. And select the region. Now this region selection again is because in case you have any new volumes coming up on source, they would get replicated as part of delta sync. If you have any changed volumes, they would be again replicated with only changed data. Schedule it will do delta sync. Now let's give ports again and load balancer service for our pod, which is launched for a transient time for the sync. And let's start the sync. It's running again. Now Swift allows various modes for access. There is a REST API, there is the CLI too, and CLI actually is the same REST API, so you can use either of them to do any kind of automation you need. And let me show the CLI. You can see jobs running from here too, and you can even look at the job progress. Let's select the job ID we want, which is running, which we just started, and you can see that it's running and it's gonna sync 2 volumes. Now those 2 volumes exist on target, and it's gonna only do delta transfer. And you can also look at the checkpoints. And let's look at the previous job as well, we successfully completed. You see a lot of data there, all the checkpoints, what all it did. And you can see the volume synced, and you also see nice summary of how many objects synced, how many volume sync, sync time for each volume, average sync time. It's also good start around networking too. Let's look at the target. This sync is about to complete. It's creating our pod. And it's gonna do the same steps again. It will create a transient pod, do delta changes like move delta data from source to target, any volumes changed, any missing volumes it will also recreate. And then it's also gonna recreate all the objects, including any missing objects. It will create afresh, and we can see our pod is up, so we should see data being transferred now. And it's transferring data now. And data is transferred now. It's replicating the actual application objects, and it's gonna also do health check after it finishes. And sync is complete now. So if you go on the target, we should see all the application services are up, and let's again connect to the WordPress application. You can see also the volume types are what we wanted it to, which is OCI block storage. And you can see already the new page we created on the source is up. Let's again connect to admin interface for the WordPress. I'll log in again with the source credentials. And let's go to the push, and you can see that both source pages are there, and also target specific page is gone. At this stage, it's a pure replica of the source. So this is what we wanted to demonstrate quickly, the cross-cloud, cross-platform, cross-version sync capability of Swift. And in today's demo, we saw Swift replicating from Azure Cloud to Oracle Cloud. and with different Kubernetes versions. We did initial application, did some application changes, and showed Delta replication too. What you saw today is limited availability release of the SIP. If you want to use this release, then please contact us on info@rackware.com. Thank you. Now we'll open this session for questions.